everybody. So I just wanted to make a quick review of what we kind of learned about this week. So this is review part 1. So the first thing that we want to talk about is that we are focusing this unit on matter. And matter is anything that takes up space and has mass, which means pretty much anything that you can think of on this earth right now, even things you can't see, like the air and the atmosphere, are all matter because they take up space and they have mass. Taking up space, the fancy word for that in science is volume. Okay, so matter has volume, and we can measure volume in two ways. If we want to get the volume of a liquid, we can measure it in milliliters using beakers and measuring cups and graduated cylinders and flasks. And if we want to get the volume of a solid, we can use a ruler to get the cubic centimeters, so the length times the width times the height. Or if we have a weirdly shaped solid, we call them irregular solids, we use something called water displacement, and we'll talk about that later. But in general, for liquids, we measure their volume in milliliters, and for solids in cubic centimeters. Okay, the other important vocabulary word we have is mass, and that's how much stuff makes up an object. And by stuff, we mean atoms, okay? And we measure it in grams. So when we're taking the mass of an object and we get an answer in grams, we're basically telling each other how much stuff is making that thing up. And the really cool thing about mass is that your mass doesn't change unless you as a human being lose a limb or something like that. You could go to the bottom of the ocean, you could go to the top of Mount Everest, but your mass will always be the same because we're not getting rid of any of the atoms that make us up. Okay? All matter can exist in these three states. Believe it or not, every single thing can exist as a solid, a liquid, or a gas. You just have to either cool it to the right temperatures or heat it up to the right temperatures. Okay? The typical states of matter that we see of objects is pretty much all we're going to see. So we're only going to ever see our mugs or our cups as solids. We're only going to see our coffee as liquids most of the time. And we're only going to see the air around us as gas. Okay? And you'll notice in red next to each vocabulary word, solid, liquid, and gas, I did a particle picture. So remember from the video that particle pictures are just drawings of the arrangement of the atoms in an object. So for solids, we're going to put our atoms all very close. For liquids, we're going to spread them out just a little bit. And for gases, they're going to kind of be all over the place. Okay? Let's take a look at each of those states of matter on their own. So solids have what we call a definite shape, meaning my mug will always have the shape of that mug unless I were to shatter it. Okay, but a definite shape means it won't change. It also has a definite volume. So if I measure the volume of a cube, I could put the cube in a tub of water. It'll have the same volume. I could take it to the top of Mount Everest. It'll have the same volume. And then finally, solids in general cannot be compressed, meaning I cannot squeeze those atoms any closer together than they already are. Okay. For liquids, they have something called an indefinite shape, meaning they will take the shape of their container. So I could take the tea in my mug right now, it's taking the shape of my mug, and pour it on the floor, and it will spread out and take the shape of the floor. Or I could pour it inside of a test tube, and it will take the shape of the test tube. Okay? Liquids do have a definite volume, meaning if I poured 32 ounces of water in my water bottle and I didn't drink any of it, and then I pour it on the floor, it's still 32 ounces. It just looks different. Or I pour it in the sink. It's still the 32 ounces of water I had in my water bottle. It's just taking a different shape now. And because those atoms of a liquid are a little bit farther apart, we can compress them a little bit, but we're not going to squeeze them very far together. The last state of matter is going to be our gases. You'll notice that they're very spread out. Indefinite shape, meaning they will take the shape of whatever I put them in. If I open my windows now, all the gas that's in my kitchen is going to escape and take up the space of the outdoors. Okay, so it's going to change the shape. I could blow all of it into a balloon. It's going to take the shape of a balloon. Okay, because it has an indefinite shape, it also has an indefinite volume. It's harder to get the volume of a gas. And because those particles are so far away from each other, I can compress them really easily. So if you think about anybody elderly maybe that you know that has to use an oxygen tank, that's compressed air. So we took as much oxygen as we could and smushed those particles as close together as we could to fit as many in that tank so that grandma, grandpa, aunt, uncle, whoever it might be, can take that oxygen with them and breathe. That's also how we get it inside of our tires, how we fill up our tires with air in our car, in our bike, whatever it is. Helium tanks to blow up balloons. I compress the helium into the tank and then I release it very slowly and it spreads all out to take the shape of my balloon. Okay, so this is just part one about matter.